Okay, now we are going to finish our discussion of right triangle trigonometry. The next thing we are going to talk about is how to solve a right triangle. What does it mean to solve a right triangle? It means to find all three sides and all three angles. Okay, so let's look at a right triangle here, where this angle is 19 degrees and this side is 13. So if we call this triangle ABC, we are solving triangle ABC. The angles are usually named with capital letters, and the sides opposite those angles are named by lowercase letters. So the side opposite angle A would be called little a, and the side opposite angle B would be called little b, and the side opposite angle C would be called little c. So to solve this triangle means that we are going to find all sides and all angles. So since we know angle A is 19 and angle B and angle C is 90 degrees, then we can find angle B by subtracting 90 minus 19 degrees. So angle B is 71 degrees. So we'll just mark that right there. Okay, now we're going to have to find side A, little a, and side little c. So let's do little a first. To find little a, we're going to have to use our trig ratios. So if we're looking from the 19 degree angle, little a is opposite angle 19. So since we're trying to find little a and we know little b, and we're looking from the 19 degree angle, then you can say to yourself, well, I need to know the opposite side and I do know the adjacent side. So if I need the opposite and I do know the adjacent, then that means that I would want to use the tangent ratio. So I'll write an equation and say the tangent of 19 degrees is equal to the opposite side, which is little a, over the adjacent side, which is 13. So we're going to solve for a by multiplying both sides by 13. So little a is 13 times the tangent of 19 degrees. So we go to our calculator and we say 13 times the tangent of 19 degrees. Remember, we're still in degree mode. So it's approximately 4.476. Approximately 4.476. All right, now we're going to find little c. So let's go back to our triangle, and if we're looking from the 19 degree angle, then now we know the adjacent side, and we want to know the hypotenuse. So which trig ratio involves adjacent and hypotenuse? The cosine ratio. So the cosine of 19 degrees is equal to the adjacent side, which is 13, over the hypotenuse, which is c. So to get c, to solve for c here, first we have to multiply both sides by c to get it out of the denominator. Then after we do that, we're going to get c by itself by dividing both sides by the cosine of 19 degrees. So we go to our calculator and we do 13 divided by the cosine of 19 degrees, approximately 13.749. So c is approximately 13.749. So that is how we solve a right triangle. Just remember, when you're solving a right triangle, you have to have all three angles and all three sides. Okay, there is one more topic we need to discuss with right triangle trigonometry, and that is the difference between an angle of elevation and an angle of depression. Okay, so if I am standing on the ground, here I am, standing on the ground. If I'm standing on the ground, and I look up at a bird in the sky. There's my bird. If I'm looking up at a bird in the sky, then the angle that I am looking up, formed with the ground, is called an angle of elevation. So when I'm looking up from the ground, the angle formed with the ground is the angle of elevation. But if I look at it another way and I say the bird is looking down at me. So if the bird is looking down at me, here's the horizon, then the angle formed looking down with the horizon is the angle of depression. So the reason why we use these in trigonometry is because whenever we have an angle of elevation, there is a right triangle formed. The height of the bird with the ground would form a right angle. And then also, if the bird was looking down at me, the angle formed with the horizon and the height that the bird is from me also forms a right angle. So we have two different right triangles here. So if I'm looking on the ground and I'm looking up, if I'm on the ground and I'm looking up, then I form an angle of elevation with the ground. But if the bird is in the air and looking down at me, then the angle that the angle that's formed with the horizon is the angle of depression. So we use we use trigonometry when dealing with angles of elevation and depression because we have right triangles formed. So if we look at an example, if an airplane is flying at an altitude, here's the airplane that looks just like the bird. The airplane is flying at an altitude of 30,000 feet. So here's 30,000 feet. And it is headed toward an airport. So the runway starts, let's say the runway starts here. Excuse me. It says, to guide the airplane at a safe landing, the airport's landing system sends radar signals from the runway to the airplane at a 10-degree angle of elevation. So from the runway to the airplane at a 10-degree angle of elevation. And the question is, how far is the airplane measured along the ground from the airport runway? So how far is the airplane? If the angle of elevation is 10 degrees, how far is the airplane away from the runway measured along the ground, which would be this part of the right triangle? So to figure this out, we have to use our trigonometry. And so since we have an angle of elevation of 10 degrees, looking from that angle, I have the opposite side, and I want to know the adjacent side. So I want the tangent ratio. So the tangent of 10 degrees is equal to 30,000 divided by x, opposite over adjacent. Okay, so we're going to multiply both sides by x, and then we're going to divide both sides by the tangent of 10 degrees, and then go to our calculator. 30,000 divided by the tangent of 10 degrees is about 170,138 feet from the runway. 170,000, forgot the number, 138 feet from the runway, which is approximately 32 miles.